Having a lot of things flying around the screen is common in many games. How do you implement this in Scratch? Hello and welcome to Game Titan. If this is your first time here and you want to learn about programming, games, or Scratch, start now by subscribing and clicking the bell so you don't miss anything. In a lot of different types of games, sprites will fly around the screen. Tower defense games, first-person shooters, real-time strategy, platform games. Even in a casino game, the dealer might shoot cards at each player, or coins might fly out of a slot machine when you win. If you just want one projectile on the screen at any time, you make a sprite, and you just have it move across the screen, like with this forever loop. This is one of the earliest programs people might make in Scratch. But there are some complications. First, you may want to have more than one projectile at a time on the screen, or more than one sprite that's shooting projectiles at the same time. You might be tempted to create more than one copy of the sprite. The problem with that is, let's say you created 3 sprites for 3 laser beams, and at some point in the game you needed 4. Your code would need to change. Second, if you remember part 3 of this series, you switched your game to use a game loop to fix some of the problems that you ran into in part 2 of this series. So the normal approach of building one sprite and having it move in a loop won't work with this new game loop approach. Keep watching this video to see how to fix these issues. The first thing you'll do is build up the movement of a single projectile. You can use this red line, kinda looks like a laser beam. Or you can use any other sprite that you want. A playing card, a pea, a bomb, an arrow, or anything else. Since we're using a simple game loop with an initialize up front and only a tick function, we'll need 2 event handlers. One for initialize and one for tick. Let's have the laser shot by a strawberry. It'll be a laser beam shooting strawberry. We'll move the laser to the back layer so it doesn't appear suddenly in front of the strawberry. The tick function runs repeatedly in our game loop over and over and over again, so we don't need a forever loop here. All you really need is a move block. It'll be more interesting if the strawberry keeps shooting laser beams over and over again. So you can add an if statement, saying that if the laser beam gets to the right hand side of the screen, have it move back to where the strawberry is, so that it looks like the strawberry is shooting the laser bolt over and over and over again. Now you have a single strawberry shooting a single laser beam. In order to have the strawberry shoot more than one laser beam at a time, you need to use clones. The way to get this done is to put the strawberry and the laser beam in the same sprite, but as different costumes. The strawberry will be your original sprite, and each time it clones itself, the clone will know to switch its costume to the laser beam. Here we can see the strawberry going across the screen over and over again. Slow it down so it's a little bit easier to tell what's going on. Add a variable called clone level, mark it for this sprite only. This will keep track of whether the current copy of the sprite is the original, which should look like a strawberry, or one of the clones, which should look like a laser beam. You can add the say block to be able to see what the value of this variable is for each of the clones. In initialize, set clone level to 0. This will represent the original strawberry. Make a new block called clone myself. Click run without screen refresh. This function is going to do everything necessary for the strawberry to clone itself, and for the clone to turn itself into a laser beam. In this function, of course, you'll have to add the actual create clone of myself block, so that that actually happens. Just for now, in order to be able to see what's going on more clearly, add this glide 1 seconds to random position block. Click on the clone myself stack a few times to make a few copies. The other thing you'll do is that at the beginning of the function, you will add 1 to clone level, and at the end of the function, you will subtract 1 from clone level. The way this works is that the strawberry, when it runs clone myself, will add 1 to its clone level. Now its clone level is 1. Then it'll create a clone of itself, which will inherit that value for the clone level variable. So you'll have 2 copies now. Both of them have clone level set to 1. Finally, at the end of the function, the strawberry will set its clone level back to what it was before by subtracting 1. That way, it'll continue to be 0. You can click the clone myself stack to run the function, and you can see that each time the original strawberry glides to some random position, clones itself, but afterwards sets its clone level back to 0. You can add this go to XY position to see it jump back to the same spot every time to make this a little bit clearer. You can see that each time after we run clone myself function, the strawberry jumps back to the lower left. In order to make the strawberry shoot laser beams again instead of strawberries, we'll need to make sure that each level of clone has the right costume. We'll need to change the costume of all of the clones with clone level set to 1 to be the laser beam. The easiest way to do that might be in the tick function. If clone level is 0, then the costume should be the strawberry, and if the clone level is 1, the costume should be the line. By building the code this way, it's easy to switch the costumes around and see what effect it has. If we want the laser beams to look like strawberries, we just switch the code, and they're strawberries. Instead of having to manually click on the clone myself function to create laser beams, we could actually add the clone myself block to our code to make sure that it gets called. Clearly that's too many lasers. So we'll add a delay the same way that we did in part 3 of this series. Go watch that video now to understand more. Instead of having the laser beams jump back to the strawberry if they hit the right edge, we'll just have them delete themselves. Now that they're clones, we can do that with the delete this clone block. There you go! Now your strawberry can shoot as many lasers as it wants. The next thing we might want to add to our game is a shop, where you can buy a laser shooting strawberry tower. If we do that, that means that we might have to have multiple strawberry towers on the screen at the same time, all shooting lasers. Again, we run into the same problem that we had before. We could just copy the strawberry over and over again, but maybe there's not enough of them. If we made 3 copies of the sprite, and somebody needed to buy 4 of these towers in the game, we wouldn't have enough. So the thing we can do instead is add another level of cloning. Now, instead of having clone level 0 be the original strawberry, and clone level 1 be the laser beam, we'll have clone level 0 be the strawberry that would appear in the shop. Clone level 1 will be a strawberry tower that you've placed into your game, and clone level 2 will be the laser beam. We'll add another if-else statement so that we can tell all 3 of these cases apart. Since we don't have a shop now, we'll just hide it. The first branch will say if clone level is 0, that's the hidden shop strawberry that everything will be a copy of. Clone level 1 will be for the strawberry tower, and clone level 2 will be for the laser beams. Why don't you say that if the space key is pressed, that will mean that you've purchased one of these strawberry towers and you'll put it down on the playing field. You can just put it where the mouse cursor is for now. In order to place a clone of the strawberry tower wherever we want on the field, we need to add some parameters to our clone myself function. One of them will be called x, which will represent the x position that we want to put our strawberry clone. The other one will be y that will represent the y position. In the clone myself function, add a goToXY block and drag in the parameters. This will tell the original strawberry to move to whatever numbers are passed in when the function is called. We potentially want to move that original strawberry back where it was afterward, so add a previous x and previous y variable. Make sure that they're marked as for this sprite only. What you'll do, you'll save the x and y position of the strawberry in the previous x and previous y variables. Then you'll go to the x and y that were passed in when the function is called. Add one to clone level as you were doing before. Actually call create clone of myself, and then reset everything back to the way it was. Subtract one from clone level, and go back to the original position that you had stored in previous x and previous y. Now you're ready to call clone myself. Drag mouse x and mouse y into the parameters. That will tell the clone myself function to make a copy at the position where the mouse is pointing. Make sure you also update the piece of code that creates the laser beams to tell it where the laser beam should start. That should just be the x and y position of the strawberry that's shooting the laser. Then you can test it out. As you press the spacebar, more and more strawberry towers appear, all shooting lasers. You can see that the clone levels are updated. Each of the towers has clone level 1 now, and each of the laser beams has clone level 2. You might notice something odd about the laser beams. They're not evenly spaced like they used to be. Pause the video here and see if you can figure it out. Leave a message in the comments if you think you did. The problem is, the time of next clone variable is being set once, for the original shop strawberry with clone level 0. Now that we have multiple tower strawberries, all of them need to separately be keeping track of when they last fired their own laser. So you can move that into the clone myself function. This will make sure that each tower that you place will initialize this variable for itself at the time it was placed. That looks much better. You can make a little change to use the mouse button instead of the spacebar. We do still need some enemies for the strawberries to shoot with their lasers. Let's see. What do strawberries like to do battle with? Ah, yes! The evil orange army. For now, to keep things simple for this video, we'll just have the orange move around randomly. We'll make a clone myself function similar to the one that the strawberry has. If you click it a few times, you'll see more orange clones appearing. They all show up in the middle of the screen because when you click the block stack, X and Y are not being passed in, so Scratch just assumes that they're both 0. We'll show both the original orange and its clones temporarily, so that we can make sure that the clone level is set properly for each of them. We can't use the glide block to move them around randomly, because that would block the tick function and cause our whole game loop to pause for a while. Instead, we'll create target X and target Y variables for this sprite only, so that each orange clone knows where it's heading next. You'll pick those randomly. Once the clone reaches its target, we'll want to pick a new target. Unfortunately, it turns out that moving around randomly was a little bit more complicated than I was hoping for. We can use the Pythagorean theorem to determine the distance between the orange, shown on this diagram in the middle, and its target X and target Y, which are represented on this diagram with a star. The distance we're looking for is the red line. The formula ends up looking like this. We can explain more about this in another video. Now that we know what the distance is to the target, we can make sure that we're moving 1 towards that distance every tick. One per tick is a little bit slow, so we can add another variable called speed. And move 1 times speed every tick instead. That's working pretty well. You can make sure that the clone has a target when it's initially created by setting random values for target X and target Y when it's first cloned. Since you have the same code in 2 places, you can create a function for it. You could call it pick new target, XY. That's a big orange army. Now you'll use what you learned in part 3 of this series to have the oranges squish when they get hit by the laser. You can add a time of deletion variable for this sprite only, so that each orange will stay on the screen with a different costume for a few seconds before it disappears. When an orange is first cloned, it'll have time of deletion equals 0. Add an if statement saying if time of deletion equals 0, then set time of deletion to 2 seconds in the future. Otherwise, if the timer has passed the time of deletion that you previously set, then you finally delete the clone. Add that code after you change the costume. Same as with the laser beam, add a new variable for the orange, so that it can create copies of itself over and over without you needing to click on the code block. You could call the variable time of next enemy to be created. So if the timer has passed that time, then the orange creates a clone of itself. And pick a new time in the future. We want this to run only for the original orange. Make sure to initialize the variable in initialize. We haven't finished the code where the laser beam disappears once it hits an orange. If you want to see that code, please see part 3 of this series. When the projectiles are fast like this, aiming at an orange is not that big of a deal. You can probably just have the laser point at wherever the orange is, and the laser will probably hit it before the orange has moved out of the way. With slower projectiles, things might be a little bit more complicated. We'll look at that in a future video. In the next video in this series, we'll make the strawberries' lasers have a limited range, the way that many towers in tower defense games work. If you liked this video, please press the thumbs up button and consider supporting more videos like this one by subscribing to the channel and turning on the bell, and watching some of the other Game Titan videos on programming, games, or Scratch. Thank you for watching, and see you next time.